In science fiction movies, death in space is often depicted in dramatic and unrealistic ways. Bodies explode, freeze instantly, or meet other gruesome ends. These scenes make for captivating cinema, but the reality of death in space is far more subtle, though no less fascinating. One common misconception is that a body exposed to the vacuum of space would explode. This is not true. While the lack of atmospheric pressure would cause some expansion of gases within the body, it would not be enough to cause a rupture. Our skin and tissues are strong enough to withstand the pressure difference. Another myth is that a body would freeze instantly in space. Heat transfer in space is actually a slow process. Without a medium, like air or water to conduct heat away, the body would gradually lose heat through radiation. This means that a body in space would not freeze instantly, but would cool down over time. It is important to remember that Hollywood takes creative liberties with scientific accuracy for entertainment purposes. The reality of death in space, while less visually dramatic, is a complex and intriguing subject worthy of exploration. The primary cause of death for an unprotected human in space is asphyxiation, or the deprivation of oxygen. In the vacuum of space, there is no breathable air. Without a spacesuit providing a constant supply of oxygen, the human body would use up the remaining oxygen in the blood within a matter of seconds. Unconsciousness would occur within approximately 15 seconds of exposure to the vacuum of space. This is because the brain, deprived of oxygen, can only function for a very short period of time. Following unconsciousness, death would occur within minutes. It is a stark and sobering fact that the vastness of space offers no second chances when it comes to oxygen. Survival in this unforgiving environment hinges on a constant and reliable supply of this life-giving element. Decomposition in the vacuum of space would follow a different process than on Earth. On our planet, decomposition is largely driven by bacteria and other microorganisms that break down organic matter. However, in space, these decomposers are absent. Near a star, a body exposed to the vacuum of space would be subjected to intense radiation. This radiation would cause the body to mummify and eventually break down into dust. Further out in space, away from the intense radiation of a star, a body would undergo a process similar to freeze-drying. While external decomposition would be halted or significantly slowed down in space, internal decomposition by gut bacteria would still occur. This process, however, would happen at a much slower rate due to the extreme cold and lack of oxygen. As of 2025, NASA does not have an official protocol for handling death in space. This is largely due to the fact that space travel has been relatively limited. However, as humanity ventures further into the cosmos, particularly with missions to Mars and beyond, establishing protocols for handling death in space will become a necessity. One option is to return the body to Earth. This would be logistically challenging and costly, especially for missions to distant planets. Another option is to store the body on the spacecraft until it can be returned to Earth. This would require designated storage space and methods for preventing decomposition. Other options include burial in space or cremation upon re-entry. The ethical, logistical, and even religious considerations of each option will need to be carefully weighed as space travel transitions from exploration to colonization.